Hi everyone. In today's video, we'll be exploring the concept of variables in PLCs, and we will learn about the types of variables and how they're used in TwinCAT. What is a variable? It is a name given to the block of memory that stores a value. A variable is defined by the following properties. It has a user declared name, which is a property to identify the variable in your PLC logic. It has a size, which is the number of bits of space that it occupies in memory, and it depends on the data type selected for the particular variable. It has a value that is assigned to it and stores it in memory. Finally, its address is the memory location where the value is stored. Variable names must conform to the IEC 61131-3 standard. Name must begin with a letter or an underscore. After that, it can contain numbers, letters, or underscores. The standard makes no distinction between uppercase and lowercase letters. Blanks or spaces and special characters, such as those displayed on the screen, are not permitted. Keywords such as or, not, bool, real are reserved for internal use and are not permitted for use in variable names and should be avoided. Variables can be declared either locally or globally. These terms define the scope of the variable within the PLC program. Local variables are declared between var and end var in the declaration part of the POU, as shown. Local variables can only be returned to in the POU in which they are declared. Local variables of any POU can be read from other POUs by first accessing the POU name followed by a period, and then the variable name. For example, there are three variables declared locally in program main. To access the F ring temperature variable and other programs, the syntax would be main.f ring temperature as shown on the screen. This variable, which is local to main, can be thus read from other POUs. However, local variables of one POU cannot be returned to from another POU. Global variables, on the other hand, are declared between var global and end var in a global variable list under GVLs. Variables declared in a GVL have global scope and can be read and returned to from any POU. The following data types are defined in IEC 61131-3 standard. Bool, which is the most basic data type for typical use in PLC programming. It is a binary data type and represents a true or false, 1 or 0, on or off, etc. A bool is represented by a single bit, but takes a full byte in memory. This is for performance reasons, because accessing individual bits within a byte can be more complex and slower than accessing the entire byte. Therefore, bools are always 8-bit. Next is the integer data type. This table shows the integer data types that are available in TwinCAT. The highlighted section shows the most commonly used integer data types, ranging from 8 bits to 64 bits. The data types prefixed by the letter U are unsigned integer types. That means positive integers only. The data types prefixed by letter D are double integer types or 32-bit versions of their counterparts. The data types prefixed by the letter L are long integer types or 64-bit versions of their counterparts. Floating point numbers are represented by these two data types, real and long real, which are 32-bit and 64-bit respectively. They are necessary for the use of decimal numbers in PLCs. Here are some examples of floating point variables. The next one is time data type. It's available in 32-bit and 64-bit versions with resolutions of milliseconds and nanoseconds respectively. Here are some examples of time variables and how they're declared and used. Like the time data type, the date data type is also available in 32-bit and 64-bit versions as shown. This one combines both date and time in one variable with a resolution of up to seconds. The 64-bit counterpart has the resolution of down to nanoseconds. String data types can accept any string. The size specification for the storage space allocation in the declaration refers to characters and is enclosed in brackets. If no size is specified, TwinCAT assumes 80 characters by default. This example shows a string declaration used in the PLC. Additional data types are also available in TwinCAT, and we will explore these in a future video. TwinCAT also allows user-defined data types based on the existing data types. These data types are either organized as a separate DUT object or declared within the declaration part of a POU. They are also distinguished based on their purpose and syntax. We will cover these data types in more detail in a future video. Normally, when variables are declared, they are initialized as false or have a null value, depending on the data type. However, variables can be initialized with a specific value at the time of declaration. In this example, we can have initial values at the time of declaration, and the variables can be initialized with those values. Constants, as the name suggests, are identifiers for values that are not intended to change during the PLC execution. Just like variables, constants can either be declared locally within a POU or globally within a GVL or global variable list. The declaration section is extended with the constant keyword for this purpose. Once initialized, constants can only be accessed in the PLC program in a read-only implementation. Please note that for constants, the assignment of an initial value is mandatory, since they cannot be returned to once initialized. To allow the variables to be able to link to I/O, they must be declared in a specific way to make them accessible outside the PLC. What I mean by this is the Solution Explorer, the PLC projects live here, and the I/O devices live here. Outputs from the PLC to the I/O are declared using %q star. Inputs to the PLC from the I/O are declared using %i star. Here are some examples of variable declaration for linking to I/O. In a future video, we will see an implementation of how to link variables to input and output terminals on the hardware side. That's it for this video. If you have any questions, please leave them in the comments. Also, let me know if there's anything specific or any specific topic you would like me to cover in a future video. Thank you for watching and see you guys in the next one.